We're seeing just a few more folks join in, so we're just waiting for a few more minutes so that we can get started.
Meanwhile, given that we are talking about RAG today, I am curious to know that how many of us are familiar with RAG? Like, what does the term even mean? What does RAG do? Wow, we have votes coming in. We have super informed audience here. So far, we have 95+% of people familiar with RAG. And that number continues to grow. All right, that's very good to know. So we have almost everyone on the call very familiar with RAG.
Yeah, so probably we can get started with the introductions and a few housekeeping rules while people join in. So hi, I'm Deepti. I work here at Founders Office. I work closely at a lot of business initiatives here. I'll take a moment to introduce the panel to you. So we have Nikunj, who's our co-founder and CEO here at True Foundry. He worked at Meta before this. He led our conversational AI team, and a lot of what we built here at True Foundry is inspired by his time there. We also have Prathamesh and Akash, both of whom are backend engineers here at True Foundry. They are our in-house RAG experts. So whatever comments, queries, questions you have about RAG, just keep them coming in the chat box. A few housekeeping rules. The chat section is always open. If you want some question to garner our attention, just pour it in the Q&A section so that our team will be monitoring both the chat and Q&A section. So yeah, just let us know whenever you have any questions, stop us, raise your hand. It's a very interactive session. Yeah, so over to you, Nikunj. Yeah, and I think we can start now.
Thank you so much, Deepti. We'll kick off the session now. So let's maybe spend a few minutes talking about what is the problem that we are trying to solve today. Right? Like, what is Cognita? Why did we build this? And then we'll get into the demo of the platform as well. By the way, Cognita, like today is the first time we are basically introducing Cognita to like openly. We have been working on this for the last many months. We have built this as an open source RAG framework, primarily for building production-ready applications, RAG applications, right? Now, this is not meant to be a replacement to amazing existing frameworks like LangChain or Llama Index. In fact, a lot of what we have built at Cognita is based on top of LangChain and Llama Index, and we expect people to continue using those frameworks, but it just helps you get to the production line much faster. That's the problem that we're solving here. The agenda for today, we'll talk about the problems here. We'll go to the demo of the platform. Time permitting, we'll go into the local installation, development, and testing workflow of our open source tool as well. And then we will actually just give you an overview of the code base so that if you want to dive deeper into this, change the code, adapt it to your own requirements, how can you do that? How can you contribute to our repository as well? And we'll keep some time in the end for Q&A for sure. Okay. So let's jump right into this. Why do we need a new framework, right? Why do we need a new RAG framework? And the basic fundamental reason is that in most, if you think about a data scientist workflow, how do we build RAG applications? We are like pip install LangChain, import LangChain, and then instantiate an LLM, and start asking questions to the LLM in some way, right? That's all of this typically goes in a Jupyter notebook, where we write one flat application. And then slowly from there, we start thinking about how to take this to production, and get things ready, right? And the moment we start doing that, realization hits that, let's say for one application, we ended up building out a particular parser, maybe some interesting sort of a PDF parser that does some OCR on your PDFs and stuff, right? Which was very custom to us. Now, you may want to reuse that parser for a bunch of other applications that get built downstream, right? So then you start thinking about, oh, I might want to modularize that one component and make that reusable, right? And the same story repeats for all these different components that actually comprise an end-to-end RAG application, basically, right? So that's what basically Cognita is trying to solve. All these different applications, all these different modules that you are using to build out the entire application are basically production ready. And each of those modules can be scaled independently in production. And again, I'll give the same parser example to bring this point to life. Imagine that you built a PDF parser for your own application that was getting 20 requests a minute, okay? And you decided to create that as a separate microservice or whatever, right? And one of your other teammates wants to use that application, but they are getting 200 requests per minute. Who is going to scale that up? Who is going to maintain that in production, right? So all of that is kind of taken care of by the design of the Cognita platform, that how can we independently scale up these modules in production, and how do we have the entire backend framework ready, right? And when I talk about the backend framework ready, you would notice that when you bring up a RAG application using Cognita, you actually get an entire suite of your backend APIs that are ready to be just scaled by themselves, right? As modules. And of course, the way we have designed this entire setup is following some of the best infra practices today. So the entire application can be shipped as a Helm chart. You can scale this independently on Kubernetes, scale this for production level traffic. And then a few other challenges that we noticed that people, our customers ran into quite a bit. For example, let's say you're building a RAG application, you have 1 million documents that are already ingested in your vector database, and tomorrow you get 100 more. Do you want to index 1 million and 100, or do you only want to incrementally index the 100, right? How do you ensure that your documents are never getting duplicated and stuff like that, right? So taking care of that incrementally, and just collaborating across teams, modularly updating these applications, continuing to build out, basically grow together as an organization as opposed to as an application. That's fundamentally the problem that's getting solved here. If you all have any questions, please feel free to send the questions on the chat and we'll keep answering. Now, from our perspective, of course, as an ML platform, True Foundry, we have been working with many enterprises. And one of the most common...
Sorry to cut you in. Can you reshare? A few people are saying they can't see the screen.
Is it? Okay.
Yeah.
Are you able to see the screen, Deepti?
I could. I can see it clearly, but some people can't see it. The audience is divided, so I just felt it's...
Okay. Yeah. Let me try this. Yeah. Okay, I'm gonna share this again. Okay, can people see the screen now?
I can. If someone who couldn't see it earlier, yeah, they can. Nikunj.
Please send out. And by the way, sometimes what happens is if you're on the phone, the shared screen actually gets minimized. So that could be another reason, by the way. But okay. Assuming at this point everybody can see the screen and moving forward. So yeah, I was just talking about that. These are the problems that we have seen our customers face time and again. And we found ourselves solving these problems through our platform multiple times for our customers, and we realized that okay, these problems clearly span broader than the customers who are using our platform, right? So that's why we decided to build Cognita. And now this is an open source framework. We hope that it adds value to your production application as well. And if you all have any questions, anything that you want to contribute to the framework, we really invite you to do that. Now, this is where I want to highlight a few important aspects of Cognita. Then we'll talk a little bit about the architecture so that we are all talking in terms of the same nomenclature, right, of the platform, and then get inside the demo. So in terms of the core features, right, it's fully API driven. So you would notice that every part, every component of Cognita, like, spins up an API that you can interact with the platform. So that is basically like this APIs are built in a manner that it's ready to be integrated to the rest of the production application. Things like incremental indexing are supported out of the box. We actually realized that a lot of the testing that happens with RAG frameworks is like, empirical. So you send out some queries, you get some response, you tweak some parameters, you keep on updating that. Maybe you're changing the prompt template, maybe you're changing different retrieval algorithms and stuff, right? So we realized that actually that part is much easier done using a UI component. And by the way, our OpenAI framework actually ships with this UI component that you can run completely locally and work off of that, right? It's ready to auto scale. So like all of these modules can be independently scaled as Docker containers. And of course, like, if you're getting a lot of concurrent requests, we'll be able to handle that as well. Cool. And then I will just briefly zoom into the architecture of Cognita. And that I am gonna directly open the open source repository and bring this architecture diagram up. So given that most of the audience is very familiar with RAG, I am not getting into the details of the RAG. I'm just going to map what you probably already know to some of the newer terminology that we are introducing. Okay. So just mental model, a RAG would require, like, basically you have an LLM that is very good at answering questions, following instructions. You're bringing in your own data set, and that data set goes through a parsing, chunking, indexing logic and makes its way to a vector database eventually, right? And then you would have your LLMs start asking questions, right? So it's very similar to a standard RAG architecture. So imagine that you have your own data sources, okay? That's one component of Cognita. And each of these data sources, like, like platform ships with a few of them, but if you have more, you can continue to add your data sources, okay? We would start with scanning your data sources. So we read the files. We would basically parse and chunk these data files that we have read. And then we can pass it through an embedding model. And again, the embedding model itself is configurable. So you can use some of the open source ones. You can use closed source, whatever open embedding models that you want to use. And eventually, all of these embeddings will make their way to a vector database, right? Now, when the actual user query hits, right, we will basically do the same thing, that we will compute the embedding of that user query and then query our vector database to find out the most similar embeddings, and we'll pass that through our answer generation module to the LLM, and we interface with different LLMs through a gateway layer so that it becomes really straightforward to switch across LLMs. And again, I'll zoom into this module a bit again. If there's any metadata enrichment that you may want to do on top of your answer, you do that, and then you return back your response. Now, the part that I want to highlight here is we have basically grouped what we refer to as, like, the offline component, as call it your everything as part of your indexing job. And just like you would think in terms of a production system, right? When you start thinking in production system, you start thinking in terms of configurations that you want to manage, right? So we have a configuration that we manage for your entire offline setup. Which data loader, which parser, which embedder, you can basically put all of these as configurations in the form of a YAML and keep that saved so that, again, these smaller modules are all reusable. Same thing, if you think about your online, like the real-time aspect of your thing, of your application, we refer to that as the query controller. And you would notice that even this is managed through a config file, basically. Again, makes it really straightforward to reuse and manage things in production. And both of these configurations are saved into a module called a metadata store. Again, Anybody who has worked on production application like configurators, any config management, etc., is a very, very important aspect. So we introduced that as a new component here. And lastly, of course, the gateway layer. A lot of you might already be familiar with it. The advantage of in using a gateway layer to access all your LLMs is like you can now start tracking all your prompts, completions that go through your LLM gateway layer in a common place, right? With the right metadata associated. If you wanted to impose any guardrails, you can implement a guardrails ahead of time, and you can impose that to whatever LLM that you're using. Same thing, you may want to do things like prompt augmentation, response post-processing. All of those layers become very, very straightforward to add, given that you're accessing everything through gateway layer. So this is primarily about the architecture, and now we are ready to dive into the actual demo of the platform. I will take a pause here to see if there is any other questions that we are missing. For sure. Okay, it would be nice to see a diagram without Cognita and with Cognita. For sure. So let me actually take that one question and answer here basically. So this is a very typical RAG workflow, by the way, that most of us are already familiar with. And you would notice that the terms are very, very similar. You bring your own documents, you take them through like a parsing or chunking logic, basically. Then you use an embedding model and you put that in a vector database, basically, right? Then you get a prompt from the end user asking questions on your document. And you may have some generation strategy, right? Like some retrieval algorithms, some embedding algorithms or whatever that you're doing, basically. So you capture that, you use whatever LLM that you want, and you generate the responses, basically, right? So this is kind of how a typical RAG algorithm works, right? Now, the part that you would notice that Cognita is solving here is we group together these offline components into let's say, an end-to-end config where you can plug and play these different modules nicely. Same thing, this online component, we are kind of grouping together each of these as a query controller layer, and we expose that config that becomes really straightforward to manage in production. And then things like how we expose these API endpoints, etc., that we don't see in the architecture diagram, but you will see as we go along with the demo. Hope that's helpful, Lenin. All right. And now we start with the actual demo of the platform. So this, by the way, is a UI layer that we have developed, and we hope that it is useful in the experimentation and the production layer both. Okay, so we start, let's say, with our data sources, and the idea is that I mentioned. And every time I will keep referring to this architecture diagram when I'm walking through this, right? So the first thing that we are covering is the data sources aspect to it. And as I mentioned that we have these 4 data sources already integrated, right? If you want, you can always add a new data source and through the open source repository, and it will start showing up here. In this case, maybe let's say I choose a local directory to upload a document that I have here, right? So maybe I'm going to upload a single README file from the Cognita GitHub repository itself and submit that as my data source. Okay. So now this data source is being created. Once it takes a couple of minutes when we get to the indexing part of it. So you would notice that now that I have the data source added, I want to ensure that I am able to do this entire processing, right? So the next step is I will read this data source, make it basically pass it through a parser, and then embed that in a vector database, right? So what I'm going to do is I'm going to create a collection, basically, in my call it vector database, right? So, and I call it like demo readme. So let's say I call it demo readme for now. Again, I have a choice of embedding model that I can use here. So in this case, I'm using OpenAI embedding. The data source that I'm going to use is the first one that I uploaded here. And by the way, this part will continue to make it more user-friendly in terms of the names that show up here. And then you can see that I have this parser config exposed to me, right? So we are looking at this part of the component so far in the demo. Here I have a bunch of different parsers that the platform already ships with, and you're welcome to add your own. In this case, I know that this is a markdown file, so I'm only using this markdown as a parser, and that's it. I'll set it out for processing. Now, while this, of course, this is going to read, chunk, process, embed, so it takes like a couple of minutes. Meanwhile, you will notice that this collection will be available to use after a few minutes, basically. Okay. Meanwhile, we obviously have a bunch of other available collections that are already ingested. So maybe I'll get to the next part of the demo through a previously ingested collection. In this case, let's say I use a credit cards collection. Okay. Again, coming here. So this part is done. There's embeddings that have already made their way to vector database. Okay. Now we are getting into this part of the equation, right? That the user basically brings in a new question of their own. So let's say if I want to ask a question on top of this document collection for me, that is, which credit cards are best for lounges? Okay. So if I ask this question, you would notice that again I have configurations available, so I can choose the model that I want based on the LLM gateway. Okay. I can change the parameters that I'm passing to the model. So how creative I want the model to be, I can change the temperature. I have different retriever algorithms that are already available, ships as part of the platform. Again, you're welcome to choose your own, implement your own retriever algorithms. You can set your retriever configurations here. So let's say you implemented a retriever which has a few parameters, right? So you can expose those parameters for you to play around with in the UI. And you can also change the prompt templates and stuff. You will get your response. You get to see the source documents from where the responses are fetched, and you're basically getting to the end of this pipeline. Now, just hinting a little bit on the collection metadata store part here, right? So you would notice that we have this query controller. And this example app that you're seeing here is basically one of the query controllers that we have implemented that basically combines some of these most common or default, basically retriever and retriever configurations that we are using. If you were to implement your own query controller, it will basically, you will be able to see that through the drop down here. Okay. Again, I'll take a pause here before I move on to the next section of the demo and just see if there's any questions that are coming in. Okay, the team is adding answers to the questions. Okay, cool. I think the team will continue to answer most of these questions offline. Cool. Then we see this moving forward. So the part that I had mentioned, that the entire platform ships by default with APIs, right? So everything is API driven on the platform. And you can, by the way, access all these APIs through this tab here. Of course, the code you can also access here. Now you would notice that all the typical components that are there are available for you to check out. So what are the available parsers? If you wanted to check that, you can actually just invoke this API and check that what are the currently available parsers. So you can see that, okay, we have 3 parsers supported today. Same thing, embedders, data loaders, query controllers, all of that. Now, when you think about creating these configurations in the metadata store, right, you may want to associate a data source to a collection, part of your offline configuration. So you have this API that you can invoke. So you can basically essentially what you're doing is you're piecing together these Lego blocks or these modules using all using APIs that you can do that as well, right? If you want to start ingesting data, you can invoke this API. And here we support incremental ingesting, which we will also demo today, right? Same thing, uploading the final things to the data directory, actually giving the answers. And this, by the way, is another configuration or an example of the query controller, by the way. So you will notice that in my query controller, I am questioning, I'm sending out questions to a particular collection called credit card. And then here's the query, sample query that I'm sending. The model that I'm using is GPT 3.5 with some of these parameters. I have the prompt template. I know what retriever I'm using. I have the retriever configuration and whether I'm streaming my response or not, basically. So you notice that this entire configuration can be passed so that like, you can check your quality of responses with different parameters. Okay. So with that, like, we have covered the demo of the online hosted UI basically, right? Now, maybe like, if we want to spend a few minutes just trying to see how this entire local setup looks like, right? We can actually set this up on my local laptop. Before that, I'll just quickly check if there's any question that requires me to jump in. Prathamesh, Akash, Deepti, if there's anything else that we should cover in the demo so far, please, feel free to add.
No, from the UI perspective, we are good.
All right. Now, here's a demo. This is a completely empty repository. Okay. And what I'm going to do is I'm going to start from scratch like any of you would, starting to develop with Cognita, right? So I'm literally going to clone the repository here and show the workflow. So once I've cloned the repository, then I will start following a couple of instructions on just installing the dependencies and stuff, right? And that's the part that the virtual environment creation, installing the dependencies takes a few minutes. So just for the sake of the demo, I have already created a virtual environment and installed this requirements.txt. You would notice that this environment is activated, the virtual environment, especially folks who do this very frequently. You would notice that this part should be very, very clear. Okay. And here I am just showing this. Like if I run this, you will notice that most of the parts are already. Oh, sorry, I have to. So I go in Cognita and then I run this, and you will notice that all the packages are for the most part already deployed. Okay. Then we have a couple of configurations that you would set up, which is creating an environment file. Once you have just set up this configuration, that what type of models, API keys, let's say if you're using OpenAI, then their own API keys, etc. We have this example file where you can add some of these configurations, and I'll just show that. And that's it. The moment you're done with that, you can now start ingesting some documents and you can start executing queries just with these two commands. So it's super production ready, and I'll show that here. And while this is happening, let me show you all one thing that I'm going to show. I'm going to demonstrate to showcase incremental indexing. So we have this repository of files that ships with the platform, which has I don't know, 10 odd markdown files, right? What I'm going to do is I'm going to remove one of the markdown files, okay, out of this repository so that when we index, this markdown file is not getting indexed, okay? So what we'll do is the first time we run indexing, we are going to index these 9 markdown files. And the thing that I will demo is the next time we run indexing, we will add a new file to this folder and we'll see how incremental indexing works, okay? This is still happening. Cool. And meanwhile, let's set up the environment here. So let me show the example. So what the environment configuration that you need to set up, right, practically looks like this, where you are providing your metadata store. And right now we are using a local ML Foundry metadata store, basically. We have the vector database and we are using Quadrant for that. You can provide your OpenAI key if you intend to use OpenAI models. Or if you want to utilize, let's say, Ollama or something, you can provide those configurations here as well. So you basically provide a bunch of these. Sorry, I should just showcase this local. Yeah. So you would basically be able to provide these keys to set up your local configuration. In our case, we have both Ollama installed and we have the OpenAI keys as well. So I'm going to copy this environment file that I already have from the previous work that we have done in this repository and without actually showing the API keys in the demo here. Okay. So now I have my environment set up, and that's pretty much it. I'm basically ready to ingest these documents. So I'm going to run this command to ingest the documents. And the expectation here is that we will ingest these 9 documents. This one other thing that I need to copy to. Yeah, so we also have a YAML, which is the config layer, right? The thing that we store in the metadata store. We also have to copy that here, which has some configurations like, and I'll just show this, what are the configurations here. So basically it just tells me that, okay, I'm going to read this particular repository. Here's my chunk size. Here's my parser, which is the embedding model that I'm using. It just tells me that entire configuration. Okay. So I just copied that here as well. And then I'm going to run my indexing job. So far, just recapping the steps, we cloned the repository, we installed the dependencies, we set up the environment config, and we set up the metadata for our indexing jobs. We did these 4 steps. We are ready to ingest the documents. This probably only takes like half a minute or so to index these documents. So it's just going through this process currently. Okay. It's a. I hope you all can see my screen still. We are seeing how many of you have built out a RAG application so far. It's an interesting poll. We have roughly half our audience who have actually built applications from scratch. Roughly 60% of our audience have built these applications. Okay, cool. Yeah, so 60-40 split amongst people who have built versus not built the applications. Okay, cool. Let's move on. So now, like, when we ran this indexing job, you would notice that it took us maybe close to 6.7 seconds to reach to index all of these. And now let's do one more step where we will ingest that one other document that we had, right? So I'm gonna move this other credit card document to this folder and then run the indexing job again. So what I've done is, like, I've added one more document to this, right? And I run this indexing job one more time. And the hope is that this one finishes faster than the previous one, because in the previous one, we were ingesting like 9 documents. This one, we are ingesting only 1 document incrementally. And we should also see the number of chunks being ingested here. In the thing, but you would notice that in this case we took like 2.4 seconds to ingest this. Of course, there's like an offset of initializing the indexing job and stuff. So you can see that, okay, like we ingested, like, it took 2.4 seconds. And now if we run, because there are no new documents, it's not going to rerun the entire indexing job. In fact, it's going to index nothing at all, basically, at this point. So like this is completely taking a hash of the documents that we have already indexed and making sure that we are not running and rerunning these jobs, because super important in production. Okay. And the last part that I wanted to cover is how you can run the entire UI on the on your local, basically. And the way that would work is you would go to our front-end folder, and there's like instructions written to run this UI. If you're on Mac, then the simple thing that you're doing is simply install Node, install Yarn, and after that, you would run these 2 commands, and you'll be able to basically run the server here. Okay. This takes a few minutes to install. So for this, and by the way, you would notice that the ingestion time in this case is practically 0 because we ingested no other documents. So because this takes a little bit of time to set this up, what I've done is I have already run a backend server and a front-end server already. And you would notice that I can actually access this entire UI using my local. Okay. So like this Cognita UI that you had seen working in production, like cognita.truefoundry.com, you're able to see that the same UI in local. You have your own local connections in this case, and now you can see that we don't have many collections. We have only ingested credit card. You can have your own data sources added, and you will see that okay, in this case also, you have everything set up. Like if you want to try out things like streaming and all, you can do that as well. So for example, which credit card is best for lounges? You can do this entire thing in a streaming response way as well. That's a part that I had missed to demo earlier. And of course, initially it does the fetching and everything, so it's not yet querying the LLM. Once it starts querying the LLM, that's when the streaming response starts to show up. And after this, I'll take a pause and I'll hand over to Prathamesh, who can walk us through the open source repository and how you all can contribute to the repository. And if you want to add your own parsers and embedding logic, etc., then how do you do that? We can cover those. I do not know what's happening with this. Maybe there's an error in the backend, or maybe not. Oh, it is streaming. Okay. Cool. All right. So Prathamesh, handing over to you.
Hello everyone. Yeah, so let me share my screen. Yeah, happy to see a lot of questions, and I see that everyone is excited, like how
By
they
the
can.
way, just one other thing, Prathamesh, before you start, I would love to see how many of our audience have already tried Cognita so far.
Yeah.
Um,
86%.
So actually, not a lot of people have tried the platform so far. I again want to encourage you all to take it for a spin, upload your own documents, start asking questions. I've linked the URL here. But yes, go ahead, Prathamesh.
Nikunj, I guess hopefully after this demo of us, everyone will be excited to try it out. Yeah. So I had a lot of questions I saw on the chat, like how to add custom parsers, how we can add these things. So I'll be walking you through the code repository. Okay. So feel free to ask questions whenever you feel like. So this was the diagram which Nikon shared, right? Like each of the modules in Cognita, sorry, each of the component is a separate module which can be independently like extended or like configured as per the use case, right? So if we'll see within the repo, we have these modules like data loaders, embedders, parsers, query controllers, re-rankers, yeah, vector DBs and all those stuff. So let's say like we have a specific loader here, like we have a GitHub loader, local directory loader. Let me just zoom it a bit. Yeah, True Foundry loader, right? All this stuff. So we have a since this being a framework, we have a specific rule here. Whenever you add anything, like add a custom loader, custom parser, what you have to do is you just have to register this loader within the init folder, init file of any within the init file of each of the modules. Like let's say I have written a data directory loader, right? Each of this loader will inherit a base loader here, right? As you will see, this is the base loader, and these are a few functions which we have to override as per our use case. And that function, once our loader is created, we just have to register it. So the Cognita will automatically take care of making it an API, which is one of our key features, right? So as being data scientist or ML engineers, you don't have to like worry about how can I expose this as an API, how can I expose this as a service, right? Like this is one of the main features that we are solving it for you, because as data science folks, you might be good at developing some features, but exposing them to towards the backend or making a backend server out of it, right? It might be a bit difficult, right? So this is what we do for data loaders, like for embedders. Like how many of you might have heard of this current SOTA embedder, right, from Mixed AI, right? So we have also integrated that Mixed AI into our platform, right, or this Cognita thing. So what we do is we take the like base embeddings class and we override few functions, right? Like one of them is like embed documents and embed query, and rest we handle some like lengths of embeddings and all that. And once we have our embedding function ready, we just register that embedding here, like mixed embeddings. So this is the main funda that we always follow. Whenever you create your own parser, own embedder, or like any one of your components, right? Those things you have to register them into the respective folder, and the API behind the scenes will take care of like exposing it as a backend service, right? So like, now one of the main things is the query controller. Like what we saw was now we saw like from this diagram, we'll see now this query controller, which will comprise of this entire flow, like the query payload retriever, LLM, the asking with the vector DBs and so on, right? So we have our controller here, the query controller. So as you can see here, one of the main features of our query controller, as I said, is like, let's say you make a RAG app right now, which can like interact with the LLM, fetch some documents, and again give you the response. Right now, if you want to make it an API, so as people can use it, it's again very simple. You just have to add this query controller decorator to your class. Let's say an example app, and you need to like have an additional overridden function called as answer. So slash answer, like you can add a get post or like get post or all kinds of HTTP request within that, right? So your like this controller will be automatically exposed as a backend API service using Fast API. So your controller will be available at slash example app, this one, slash example app slash Fast API, slash example app slash answer. So let me walk you through a simple query controller that we have written. Actually, it's like it has a lot of points. So what we do is we first get the vector store, like as Nikun showed you, right? Let me just open up the metadata file, right? So this is the collection name, what we are giving. Then we have the data source, we have the parser configuration, we have the embedder configuration, right? And by default, what we are using is we are using a quadrant vector store for us. Right. So what we do is we get the vector store, we get the prompt template, we get the LLM. So even if you will look at the LLM, what we do is like depending upon what kind of keys you have provided, we choose from the different LLM models, be it an OpenAI LLMs, or be it an Olama, or be it like models through a True Foundry LLM gateway, right? We can effectively route your request to each of those LLMs. Then we have different kinds of retrievers also available within that, like a simple vector store retriever, or like document re-ranker retriever is also called as contextual compression, or a multi-query decomposition retriever, right? Or re-ranking with a query decomposition. So we have implemented like different types of retriever, even the streaming response. And all this file, now all these modules are clubbed together as a LangChain chain, right? And this is passed with the context, which we take from the retriever, and then we give it the question. Finally, we get the answer, and that answer is sent out as a JSON response, which you saw the Nikunj, which showed you on the UI, that we get the answer and then we get the docs. So this is pretty much the entire structure. So the things you have to remember is every model will have a base class. If you want to contribute to this repo, and which is highly encouraged, every model will have a base class. So as to add any custom parser or any custom data loader, you have to inherit that base class. And then once all the functions of that classes are written, then you have to register that data loader or the parser or the custom query controller. So as you will see here, like we register our query controller as an example query controller here, right? So within the parsers, if I have to show you the parser register, right? So we have implemented different parsers like Markdown parser, text parser, a PDF a table parser. Someone had actually asked, like, do we parse tables? Yes, we actually parse tables here. So we see like we do parser registry within this register parsers, and we have different parsers enabled, which inherit from the base parser. Similarly, we have for embeddings, then we have for data loadings. So this is how our things are structured. Mostly all contributions will be here. And then we also have, this is the main app which we serve from the Fast API. Then this is the server app, like all the backend APIs which you saw earlier. Yeah, these are the ones, the backend APIs. Here we are integrating them, right? And next one is again, yeah, the indexing or the indexing flow, where we all handle the incremental indexing and all that stuff. Right. We also have one of the features which is not commonly seen, Like, let's say you are working on a project or an app. Okay. Now you want to make some changes to that app, but you don't want to disturb an existing application what is made. Let's say you have an app A. Now what you want to do is you want to make another app B based on top of an app A. Okay. So you have a vector DB where you already have done embeddings on lot of documents, let's say 100,000 documents. Now you want to create another app, okay, which is based on top of app A. So we also have features for migration of this. Basically, we currently support the quadrant migration. So there, what we can do is we can replicate the quadrant vector DB entirely, so that you need not embed these all documents, 100,000 documents once again as a separate collection, and you can build all other enhancement on top of this. So what it saves in terms of cost, if you're using, let's say, OpenAI embeddings, or so you essentially save embedding all these documents both in terms of time and money. So this is also one of the features that we offer, like we can migrate entire collections across the apps, so that you can build different variations of each of the app without having to reindex each and every time. So yeah, that's a quick demo here. So if we have any questions, like we can get going with that.
Hi,
Perfect.
I'll just take a minute before we open the floor for questions. I've dropped a link in the chat box just to gauge the interest of the crowd. Because we've just launched our open source module. We want to know more about what you are interested in. Also, if you want to contribute to the open source, or you want access to the platform, or you want a more personalized demo from our end for advanced RAG use cases, just type in your interest in the form and we'll be happy to reach out to you to take it further. Okay. Yes, and there's a poll up again. Do answer the poll, but also keep filling the form. Yeah.
Yeah, so let's see if we have any questions. Yeah, most of them have a question like they missed the intro. Like what are the main problems Cognita is trying to solve? Yeah. Yeah. Is it any different from LangChain and stuff? Yeah. So one thing we want to make clear is we are not like Cognita versus LangChain or Cognita versus Llama Index. Okay. We are building on top of it. What we are making is the production use case easy, like shifting from experimentation phase on Jupyter Notebook, how we can bring that scenario to the production setup where things need to be modular, where multiple teams can collaborate among themselves, right? Where things are scalable. That is what we are trying to solve. Let's say one of the use case, right? In production, like if you are trying out LangChain or Llama Index or any of the RAG libraries, or in experimentation phase, what you generally do is you just try to ingest like 8 documents, 15 documents, or max 20 documents, right? But in production scenarios within companies, you might have 100,000 documents, right? Or like a million documents. So at that point in time, when the scale increases, we need to handle different things. Like we need to batch those documents, right? Also, then we need to chunk those documents efficiently. We need to take care of all the memory constraints that are happening, right? All this thing. Then also we need to take care of indexing, that we are not indexing the documents which are already indexed. We need to take care of what was the last modified timestamps this document had, right? So all these things are taken care by this our framework, right? So what we give you is a guidepost, like how you should be moving towards developing RAG applications where multiple teams can collaborate effectively, like using the same code base. Like let's say we are having 4 teams that want to develop the RAG applications, right? So each one having to have a separate a separate environment in Jupyter Notebook. They can use the same repo. They can add their parsers within the same folder. Each one of them can have a different parsers, like which are inherited from the base parser. They can add multiple parsers there, and then each of the parsers can be used by multiple teams. Like let's say team A develops a parser. Let's say there comes a use case in team B which they want to use, right? So they can effectively directly use that parser as is. So this is what we are trying to solve. We are trying to solve the problems which are faced in production. Under the hood, we are not doing anything miraculous that like no one else has done in this RAG algorithm, right? This is not we are trying to solve. We are trying to solve problems which are typically faced by users in production. How do you deploy the LLM models, right? Like where do you host that as a service, right? These things are taken care of by this platform.
And we have a couple of other questions here. I noticed that about multimodal RAG that I just answered. We have like, mixed bread. There is a rerank. Yes, so more re-rankers. We plan to integrate more re-rankers as well. And we really want you all to also contribute to the platform and add these re-rankers as well. Jayesh is asking, can you like how to deploy in prod? I imagine like the question is that how do we deploy this in production? So maybe like what we can show, like this is something that we can even show this quickly, which is how we are kind of doing this for Cognita right now, by the way. And we are doing this on top of the True Foundry platform, but it's something that like you all can actually do using Kubernetes as well. So I'll just briefly cover what happens when you're running Cognita, right? So by the way, just as a quick reminder, right? Like when you're running an application like this, you're basically spinning up a lot of these microservices, right? So microservices could be a vector database, an LLM gateway that may have some open source LLMs. You may have a backend that's orchestrating the entire thing, a front-end application. So there's a lot of these app microservices that are running, right? Now, the way this ships within True Foundry is we have this entire thing can be shipped as a Helm chart, and or think of this as a composite application, which is like a collection of microservices, by the way. So the actual Cognita public microservice, when you go inside True Foundry, you would notice that we have all of these microservices running independently. So you will notice that we have a backend. We have a couple of pods that are serving the backend. We have different pods that are serving the vector database. So you can see that we have a couple of pods that are serving these microservices. Then we have a pod that's serving the front end as well. So basically this entire composite application comes out as like, different microservices that are running independently. And to do all of these within the platform, I will show that like, deploying these, you don't have to do these independently. They can actually be deployed all together. But at the same time, you're also able to see things like, like let's say you ran an indexing job, right? And you wanted to see what happened with my indexing job. Were there any errors or something? Were there any failures? So you can see what failures happened. And you can see the status of all your indexing jobs as well. How long did it take to run each of these indexing jobs? Besides, one of the other things that I wanted to also mention is if you want, these applications can also be like, independently scaled as well. So like, as I was saying that like, if you're running, let's say, an endpoint, a backend applications, a vector database, you don't have to basically deploy these independently. The moment you submit these, this entire composite applications actually get deployed and you get the entire UI up and running. And of course, the code that we are using to bring this entire thing up is coming from our Cognita repository, basically. Okay. Any questions? We are happy to take further questions. And maybe like just one other thing that I wanted to highlight here is Cognita is actually, as I mentioned, is built to run on any infrastructure. So we use like things like Docker and Helm chart that we export that can be deployed on whatever infrastructure that you want, AWS, GCP, Azure, practically any infrastructure that you want to run this on, including True Foundry. Yes, and we would love for you all to join the Slack channel as well. Please join the Slack channel, ask any questions that you all might have. Yeah.
Yeah, I
And
see, Raj, you've raised your hand. I've just, you can ask your question.
yeah,
Just,
we have unmuted, right? Like people can actually, just unmute themselves and ask questions. Yeah. Raj, just in case you want to ask your questions, unmute yourself, ask questions. We have a few more minutes. We can take questions here.
yeah, I think Raj isn't responding. So in the meantime, folks, just please fill in the form. There are few people who've not yet filled the form. If you'd, and also join the Slack channel for discussions around Cognita, RAG, LLMs, GenAI in general. We love to, we're trying to build a community around our open source initiative, and it will really help support our open source endeavors.
Yeah, guys, please contribute because every great product in open source is built by the community. So we'll really require your support to make this product a great one.
This is just the starting point. Like, we have just captured some learnings that we have so far working with our customers, but like there's so many other problems that people are facing. And if you all like keep adding to the repository, like, we'll be able to solve this problem for the community overall. There's another question I would like to know how you insert multi-hop and advanced RAG patterns while minimizing LLM calls. From Ashwin.
Yeah, we have something similar to this, like a multi-query retriever, which decomposes the query. But yeah, these are like generally for any of the patterns, it's just about implementing the algorithm, right? So if you are able to like convert that algorithm to the interface that we have, or even create your own interface, this should be easily doable. That's not a problem
Yeah.
here.
And I mean, like, if the focus, Ashwin, is on like, minimizing the LLM calls, to be honest, like, as a framework, it's not necessarily in the control of the framework of how many LLM calls are getting made. Of course, unless like, you design something like a multi-agent conversation yourself, for example, in which case there are some of these things that are automated. So it's a lot of control that is in the user's hand, to be honest, of how many LLM hops that you want to make, basically. We have a suggestion to keep the package. So any suggestions to keep the package dependency independent? A lot of clients and package will make the repo bloat when other custom parsers are allowed. It's gonna add more. Make sense? We'll work towards this as well. Thank you. All right. Our team will hang around here for a few more minutes in case people have more questions. Otherwise, we are right on time. And yes, we absolutely invite contributions. So I'm not able to pronounce your name here, MOGITHPN, but please do contribute to the repository. Yeah. And please join our Slack channel. We welcome questions from everyone.
Currently you can see we have some open issues available. If you go into future work of the README, like one of the things we have partially done is like integrating with VV8, right? So that's one of the things that is still available. So if you can like at the, I feel that will be a good project because you will get to know a hang of how incremental indexing is done. You can take a reference at how we are doing in single store, how we are doing the same things in this quadrant DB, right? So if you want to take a go at how you can make the similar things available for VV8, so we would be very much happy with that, and the community shall surely benefit.
Okay, so if nobody has any further questions, we can end the webinar. Happy to take any more questions. We can stay back. Any questions around RAG, LLMs, GenAI in general, happy to answer any of your questions. Thank you, guys. Thank you for your support.
Bye-bye. Bye, everyone.
Bye, everyone.
Bye, everyone.
Bye, everyone. Thank you, everyone. Bye.